Good evening. My name is Vignesh Analaki Manonidhi. Matrix number 10 DKM 21 F1 1028.
Hello everyone, my name is Sharvideshan Analalaki Kursami. My metric number is 10 DKM 21F1140 and I'm from DKM 2C.
Hello everyone, my name is Tan Chen Wei. My no metric is 10 DKM 21F1136. I'm from DKM 2C.
Introduction of applications of integration. Area under curves in stadium. Integration plays a significant part in human daily life, and it is critical that we have a true understanding of it. Integration has been widely applied in a variety of sectors around the world, including education, engineering, physics, architecture, electrical charge, average value, and many more. Integrals depict the maximum area and volume required to fill a given space. In stadium design, for an example, the notion of integration is used to estimate the area and volume of the dome's bottom to accommodate as many seats as possible. The area under a curve is divided into multiple little portions and added or integrated until the final situation is found. Area under a curve can be found by using integration. The formula is the area between a curve and x-axis is given by a equals to integrate y dx, and the area between a curve and y-axis is given by a equals to integrate x dy. Our question for this presentation is calculate the generated volume between the curve y equals to 5x minus x power 2, the x-axis x equals to 3 and x equals to 5 is rotated to 360 degree about the x-axis, then sketch the graph.
So today I'm going to explain to you all how to do the calculation for question number 7. So firstly, we see the volume is equal to pi limit 3 to 5 y square dx. Then we integrate that and we find y in terms is equal to 5x square minus x square. Then after that we form a table to substitute all the values into x to find the value of y. First we substitute x to 0 and we get y is equal to 0. Next we substitute x equal to 1 and we will get y equal to 4. Then next we substitute x equal to negative 1, we will get negative 6. Then fourthly we substitute x equal to 3, we will get y equal to 6. Then lastly we substitute x equal to 5 and we get y equal to 0. So next pi, we solve the following equation by doing pi in terms of 3 to 5 and 5x minus x square. So we should integrate all of this. We should integrate this first and then we substitute the values what we get from here to solve the equation, and then finally we get 496 over 15 pi. So that is all from me. Thank you.
The task have been given is to sketch the graph. Before we sketch the graph, we need to find the limit of x and y. Okay, this is the value of the limit and the intercept. Next, after we find the value of limit, we can sketch the graph. Okay, this is the result of the graph. Okay. Today I want to talk about conclusion. From this presentation, we have learned to solve problem using integration. As stated in the question, we are required to find the area of the shaded region using integration method. To find the answer, we have to apply integration method. Moreover, we also enhance our skill on sketching graph and finding the limit of the shaded region. With integration as mathematical technique, we have been able to reach the solution of the different method used. The method bring a simpler and clear way thus can be used for practical data. In summary, we can say that mathematics are very important in our daily life. So, we have to learn them as much as possible to understand the world where we live. Mathematics may not teach us how to add left or minus head, but to hope that every problem have a solution. That's all from me. Thank you.
Q&A session. Question 1. What does the area under a curve represent?
The answer of the question 1 is the area is under a curve basically signify the magnitude of the quantity that is obtained by the product of the quantity signified by the x and the y axis. Question 2. What is the area under a curve called?
The answer for the question 2 is the area between the curve defined by a positive function f and the x-axis between two specific values of y is called the definite integrals of f between those values.